So whether in the legal industry, customer service and customer engagement, the finance industry, healthcare, broader industry including manufacture, or the burgeoning industry of humanoid robots, there's a call for a central computational unit to perform units of work and where we can program that unit of work. So what I'll be showing is a general purpose artificial intelligence unit that we're calling the Observational State Machine. Hi, Victor Morganta here from FactEngine. We're going to look at a programming unit for general purpose artificial intelligence that FactEngine and our invention partner have invented for orchestrating workflows across a wide range of industries. This video is titled Programming the Large Language Model, and where prompts are coming to be known for large language models as ways of programming large language models. We can also use prompts for large language models to orchestrate such things as RAG, so Retrieval Augmented Generation, and also implementing workflows, so making decisions over workflows, implementing the workflow in terms of orchestrating the workflow and achieving our desired results. We'll do that by looking at an example of the use of the Observational State Machine, or the OSM, and we'll look at a use case within customer service or customer engagement, and one that is widely recognized around the world so that it's easy to understand how the OSM works and applicable across a broad range of workflows. In terms of workflow orchestration, we're all fairly familiar with, for instance, modern day chatbots on websites and even on phone systems, where a workflow is implemented as an ostensible flowchart that gets us from the beginning of the workflow to our desired result, and we're going to be looking at ordering a pizza using a chatbot with the OSM, following a set of steps within a plan, so plans and steps that from the observational view looks like a flowchart, and where many implementations actually use flowcharts to orchestrate workflows, but and then where the observational state machine is different in that we observe the entire workflow, so the entire flowchart, from a bird's eye view, and where we can jump to any step within the workflow as the conversation, for instance, or events in the outside world take us. So the general purpose AI unit works as an observational state machine where we can picture states within a flowchart, but where we take a bird's eye view where we can picture the whole flowchart at once, such that we can have dynamic workflows. So let's have a look at an example of a use case in the customer service and customer engagement arena, which we're all familiar with, which is the process of ordering a pizza. The demonstration I'm going to give could be over a phone, or via a chatbot on a website, or via an app on somebody's mobile phone, for instance. We're going to give our demonstration of the OSM in the customer service environment from within the Boston conceptual modeling software, and for these reasons. So Boston has a chatbot inbuilt into Boston. Boston allows us to set up a task to execute as a observational state machine. Boston hooks up to databases by default, both relational and graph databases, and where we can do retrieval augmented generation directly using the chatbot and the OSM within Boston to be able to configure the OSM for a particular workflow. So for a demonstration of taking a pizza order, we've got a pizzeria database which we can both see in Boston as a relational model or as a property graph schema model, because Boston and Fact Engine lets you work over relational and graph databases. The property graph schema view is a little bit easier to understand and conceptualize than the entity relationship diagram view, so let's focus on that for now. So we have a pizzeria that, as a pizzeria chain, for instance, the same pizzeria brand can be at multiple locations. Any one particular location for that pizzeria can have a menu, and a menu can have a selection of a particular selection name. And if we look at the data behind that, we can see, for instance, that we have a range of, say, antipasta, pizze bianche, pizze rosse, a bambini menu, pasta, and salads. And then we have our prices for our various items. So for instance, a large margherita pizza is a pizza rosse, and its price is $15.90 at that particular pizzeria, identified by 1 and location 1. So we've got a pizzeria set up. We've got Joe's Pizza, and where we want to take orders for customers, where an order item is for an order, and ultimately we get payments of a particular payment type for that order. The virtual analyst in Boston is a chatbot, and I'm running the OSM, so I've got the OSM mode here. I'm going to run a task that I set up, and I'll demonstrate that first, and then I'll show you how to set up a particular workflow in Boston. So let's execute a task, so a workflow called Pizza Order Taker. But just before I do that, I'll mention that the voice that you're going to hear from the OSM, so from the customer service agent, and the name of the agent, etc., are configurable. And also, this particular demonstration, while done in Boston, could be via a chatbot on your website, on somebody's mobile phone, or could be hooked up to a voice system for telephony, so where you could take orders over a phone. So I'm going to run the task Pizza Order Taker.
Welcome to Joe's Pizza. How can I help you today?
So welcome to Joe's Pizza. How can I help you today? Hi. Do you have any salads on your menu? So a typical customer inquiry, the OSM isn't following any particular script and is going to check the selections. Yes, we do have salads.
Yes, we do have salads under our Insulate menu selection. Let me list the options for you. We have 2 delicious salads on our menu, Greca and Mista. Would you like to add one of these to your order?
So let's find out what's on the Greca. So what's on the Greca, please? So the OSM's interacting with the database with schema aware and database
I'm just checking the toppings for the Greca salad for you. Won't be a second.
database aware queries.
The Greca salad includes mixed lettuce, tomato, cucumber, red onion, olives, feta cheese, and oregano. It's dressed with olive oil and fresh lemon. Would you like to order the Greca salad today?
Okay, sounds good. Sounds good. Do you have any pizzas with olives?
I'm just checking our menu for pizzas with olives for you. Won't be a second. We have several pizzas with olives on our menu. The Napoli, Capricciosa, Ortolana, Il Forno, and as a topping on the Mista salad which you were interested in. Would you like to order any of these pizzas?
Well, I'm going to ask another question. So, what do you have for the little ones? So, for children. So I'm saying, what do you have for the little ones? And
I'll just take a moment to look at our menu for the little ones. For our little ones, we have a special Bambini selection, which includes a delightful margherita pizza and a tiny-sized gnocchi dish, both perfectly portioned for children. Would you like to order something from the Bambini menu?
so the OSM utilizing a large language model is intelligent enough to know that when I'm speaking about little ones, I'm probably looking for a kids menu. It's found the Bambini menu, found the items on the Bambini menu and read those out for me. So I'm going to order a Napoli pizza and a Greca salad. So can I have a Napoli pizza and a Greca salad, please?
Sure, I'll just check the price for a regular Napoli pizza for you. Great choice. The regular Napoli pizza is $15.90, and the Greca salad is $15.90 as well. Would you like to go ahead and place the order, or is there anything else I can do for you today?
Now what's interesting there is that I'm not particularly following a script because I've placed an order for 2 items at the same time. Can I get extra feta on the Napoli, please? Excuse me.
Absolutely. Extra feta cheese on the Napoli pizza is no problem. That will be an additional 50 cents, bringing the total to $16.40 for the pizza. With the Greca salad, your total comes to $32.30. Would you like to pick up the order, or should we deliver it to you?
So I've got a salmon-coloured message there, which is just for debugging in Boston and for testing. So we've calculated a total for the order. I've been notified that it's an additional 50 cents for the feta cheese, extra topping on the Napoli, bringing the total of the Napoli pizza to $16.40, and calculated a total price for the order. So I'm just going to say that will be all for today, please.
Thank you. Just to confirm, is this order for pickup or for delivery?
Now, for simplicity for this demonstration, I'm just going to say pick up please.
Got it. Your order will be for pickup. May I have your name for the order, please?
So I'm just going to let her know that I'm Victor.
Thanks, Victor. I'm just updating the system. Won't be a second.
So just making sure that everything's in the database now.
I'm just updating the system. Won't be a second.
Keeping us informed, so being quite communicative, making sure that we know that Brianna's working for us. She's double checking the order, so the Napoli pizza with the extra feta has been noted. I'll now add the Greca salad.
I'm just checking the price for the Greca salad for you. Won't be a second.
Double checking the price on the salad.
I'm just checking the prices for the items you wish to order. Thank you, Victor. Won't be a second. Your Napoli pizza with extra feta has been noted. I'll now add the Greca salad to your order. Just a moment. Just adding the Greca salad to your order, Victor. One moment, please. I'll just confirm the total price for your order, Victor.
So
one moment, please.
Confirming the total price for the order. Here we go.
Your total today is $32.30. Thank you for your order, Victor. Your Napoli pizza with extra feta and the Greca salad will be ready for pickup soon. Have a great day.
Thank you. See you. Oh, spelling mistake there. So there's our order. It's been placed. And if we check the database, the various items will be in the database, and we've navigated our way through a workflow which isn't particularly straightforward because you can jump anywhere around within the workflow. So that's
I'm just finalizing the details of your order and making sure everything is correct. Won't be a second, Victor.
Normally you'd get the bot to hang up at that stage, but just going to confirm one more time.
Thank you, Victor. Your order with the Napoli pizza with extra feta and the Greca salad is all set for pickup. The total comes to $32.30. We'll see you soon. Have a wonderful day.
Great, and we close the call. So that's a demonstration of the observational state machine within the customer service and customer engagement arena, doing retrieval augmented generation, where data is retrieved from a relational or a graph database, rather than perhaps say a embeddings database with vector similarity search, and where we followed a workflow and orchestrated that to be able to achieve an order for a pizzeria. Now I'll move on to demonstrating how that's set up in Boston. So let's have a look at how a executable workflow can be set up for an observational state machine within Boston, with knowledge that the OSM can be applied to any framework in AI that uses, say, for instance, Python. This particular instance we're running under .NET, but the OSM as a tool is very easy to implement also within other languages and within other frameworks. So I've got a menu item up here for OSM. We're going to edit a task called the pizza order taker, and a task embodies the functionality of an observational state machine. We have a task name, so pizza order taker, and a description, so helps the customer order a pizza, creates the necessary records in the database. We have goals, so a short description of the goals and a long description. So record the order placed with the pizzeria in the database. The ultimate goal is to create a table data instance in the order and order items tables in the database. And of course, we can store items in the payment type for credit cards and locations for customers and credit card details for customers, etc. And the long description, I've pretty much got the same thing here, but I've added that we're effectively operating as a good enough artificial intelligence that approaches artificial general intelligence. And in this instance, you'll execute the script and act as a friendly staff at the pizzeria taking the order. So it's as simple as that. The workflow itself is set up in what is known as PyJSON, so pseudocode in JSON. And PyJSON, the syntax is copyright to Victor Morganti and licensed to the OSM inventors. It's a simple scripting language that is line numbered pseudocode with goto statements with the normal control flow statements that you would see in normal programming languages. The only thing is that everything's in pseudocode and natural language. So for instance, in line 3, if we greet the customer and they say that they want to place an order, we go down to line 30. Otherwise, we go to line 4 and we can close out the conversation gracefully. Because the OSM is smart enough, the OSM can jump to any step within the workflow or make decisions on its own to query the database to answer customer queries over a limited set of database queries which we provide for security purposes. So we have an action, status, whether it started or stopped, and any annotation there. And that annotation, when you work with us, will show you how, can be either just comments or instructional for specific task purposes for the workflow. So once again, the PyJSON, pseudocode in JSON, is line numbered pseudocode with goto statements and control flow structures much the same as any programming language. We effectively program a large language model using PyJSON, and the OSM in cooperation with a large language model is smart enough to navigate anywhere within the workflow it needs to at any particular time, and then to be able to interact with either APIs or, in this case, say a database, and effect the ultimate goal of the workflow, working through the workflow as it's described to the OSM. Now we can view that as a tree or as free-form text, and when we say programming the large language model, we ostensibly create a program for the OSM to operate over. This particular task is set up to interface with the pizza order taker model. So on the left we have the pizza order taker model, and that model inside Boston is hooked up to a database which we had a look at previously. So then we have a template which basically provides extra prompting for the OSM to operate over, and we've got some policies at the top here, and for instance, we don't sell drinks, please don't make up any items that are on the menu, and we have what's known in the OSM a self-assembled context space which provides the relevant details for a large language model acting as a near AGI interpreter of our template and context space provided by the OSM makes decisions over the workflow, the types of queries that users or customers can make and interact with the customer. There are a set of standard functions that come with the OSM, and we have a limited set here that can be added and removed from the task. So running a fact engine query, which I'll show you in a second, to answer customer inquiries or to provide data to the OSM to operate over. Marking a step as complete. Even though a step may be marked as a complete, the OSM is intelligent enough to revisit that particular step within a workflow of a task if it needs to. Deleting any table instances or upserting any data into the database, or simply providing a response to the user or the customer. The meat of the OSM for querying the database in this instance is using Fact Engine, and Fact Engine is the controlled natural language query language sold by Fact Engine, so the namesake of my business, Fact Engine, and where we can nominate a query name, so the pizzeria menu, the description, the menu of the pizzeria, and then a Fact Engine query. So this particular query reads which pizza, so the pizza location, pizzeria ID and location. So this particular task is set up for Joe's Pizza, has which pizza name, and it has which pizza size, and has which pizza price, and which menu selection. And we saw earlier that we even put salads in there and under the insalata menu selection. So even though we're using the pizza names size start date table within the database. Now, to give a quick demonstration of Fact Engine, if I go open Fact Engine inside Boston and run a query, I can say which customer placed an order, got to spell right, order that has order item, and I'm going to say a regular Napoli pizza, and hit go on that, and we just got a generic customer, say for a pickup order, but if for an in-store order even. Now we do have, I believe, an example with somebody's name against it, so a family Napoli. Okay, so Mark Williams. So a few people were just generic customers, and we placed the name of the customer against an order when it's placed in the order table. But this particular order down here, so Mark Williams, placed that order. So which customer placed an order that has order item family Napoli. So Fact Engine query language, or FECL, is a very easy query language to write. It's also perfect for large language models because they can quickly and easily understand how to write the queries for a particular customer inquiry. Now, this particular inquiry, the pizza menu, is not a user inquiry. It's used to populate the context space for the large language model to operate to execute the workflow of the OSM. But if we find a particular query that a customer might ask, so what toppings on pizza name and where the query finds the toppings that are on the nominated pizza name. The query is pizza name and then pizza name in less than equal signs has which pizza topping. If I take that query, put that in Fact Engine, and change pizza name to say Napoli, we can see what's on the Napoli pizza. So anchovies, capers, mozzarella, olives and oregano. So when a customer asks a customer inquiry, the OSM in conjunction with the large language model is intelligent enough to realize that it has if I just shrink this, a query that is a user query answerer, what toppings are on a particular pizza. Look at this particular Fact Engine query, which is in natural language, which our large language models are proficient at. Substitute the name of the pizza for, say, Napoli, and return the toppings. So Fact Engine query language is perfect for working with large language models, modern day artificial intelligence, and under the observational state machine. And the corollary is that if we weren't using Fact Engine query language, we'd have to have say SQL or Cipher being interpreted or generated by a large language model, which I believe at this stage is still prone to errors, and there's far less chance of errors if the large language model is proficient at natural language and our queries are written in natural language. So we have some other queries here. So get the order, total price, which pizza has a particular topping. So when I asked which pizzas have olives, we found pizzas with olives, and we're getting another query to get the price of a pizza by size. So if we wanted to know the price of a large family Napoli pizza, what dishes are in a particular selection. So we asked, what salads do you have? And I was courteously responded with the range within the salad range on the menu. Confirming the order, item details, and which pizza has which topping. So that returns all the pizzas and all the toppings, and we can have a list of all the pizza toppings. This task is still open, and if I run a query or ask a question to the task, so if we haven't hung up on the customer, I'm going back now, I'm saying, oh, can I ask the range of toppings that you have? So the OSM is intelligent enough to list all the pizza toppings, come back to us, and give us
Certainly, Victor.
a range.
I'll just check the range of toppings we offer on our pizzas for you. Won't be a second.
Offer a range of what is offered. So ham, salami, Italian pork sausage,
Thank you for your
pineapple,
patience, Victor.
capers.
We have a wide variety of toppings you can choose from, such as extra cheese, parmesan, oregano, fresh tomatoes, red onion, garlic, fresh basil, olives, mushrooms, ham, salami, Italian pork sausage, pineapple, capers, local prawns, and many more. Is there a specific topping you're interested in?
Right, so there's a wide selection of pizza toppings. So it's very interesting. It's technology that works today, and the OSM is intelligent enough to realize that a customer was asking, list all the pizza toppings, go to the database, get all the pizza toppings, formulate a response, and courteously get back to the customer with a response in a friendly manner. So thank you very much for watching. That's the observational state machine within Boston. The OSM is available to customers for implementation with their website chatbot. If you want to work with us to hook that up to a telephony system, we'll work with you, with our invention and implementation partners, to do that with you. And we look forward to engaging with you to achieve the outcomes you need for workflow management using artificial intelligence. Thank you.
Thank you for watching. I hope you enjoyed the video. I'm Victor Morgani from FactEngine. FactEngine provides consulting on knowledge graphs, object role modeling, property graph schemas, and relational models. And of course, FactEngine is the author of the world-leading Boston conceptual modeling software. Thanks again. I look forward to speaking with you soon.